Here's our example 4 for disk and washer method. The reason why I say disk is sometimes you have an actual solid of revolution. Sometimes you have a washer. Sometimes you could have a mixture thereof. And so I'm going to start off with this example. It tells me to work with the parabola y equal x squared plus 3. So I'll graph that. Got this parabola that is y equal x squared plus 3, so it means it starts 3 units up. I'll draw me a parabola. And because they're only dealing with the first quadrant, I'm only drawing the parabola in the first quadrant. You say, how do I know that? Because it tells me x equals 0. It's giving me these boundaries. There's my x equals 0. It says y equals 0 and an x equal 2. So they want me to work with just that region. And they're going to tell me first to revolve this about the x-axis. So we'll do part 1 about x-axis. Well, I have boundaries here. I know I'm going to start at 0 and end at 1. So I've got my x equals 0, or pardon me, x equal 2, and end at x equal 2. If I'm revolving this about the x-axis, I don't have any void in that. This is all solid, meaning that when I run my radius here, I am only touching a shaded region. I don't have any voids in that, which means that I would be working with a disk method. And so my volume would be the simple volume equals the integral from 0 to 2 pi. The radius here happens to be x squared plus 3 squared, because remember it's pi r squared dx. So that's a pretty straightforward problem. I can put it into the calculator just as I see it. Nothing to freak out over there. So I go to my y equal, clear everything out of there. I'm going to do my pi parenthesis x squared plus 3. That quantity gets squared. And then I do second calc, option 7. I want to start at 0 for my lower limit, and then I'm going to end at 2. And that's given me a volume. I noticed it didn't show a picture there. It means the graph is well above the screen there. I wasn't really worried about it. And it tells me my volume is equal to 126.920 units cubed. Now I want to do an example 4.5 off of this, and you can probably guess what I want to do. I want to revolve it about a different set of axes. So let's start the same problem here. I'm going to call this example 4.5. I have y equal x squared plus 3. I have the y-axis. I have the x-axis. I have x equal 2. Oops. X equal 2. And let's go ahead and graph this. So I have that same region. 1, 2, 3. Goes up like this. It's that region there from x equals 0 to x equal 2. Only difference? Let's be weird. Let's revolve this about x equal -2. If I revolve that region about x equal -2, it's going to be set up as 2 different integrals. You say, how do you know that? I know that because when I look at these radii, they change. They always go out here for the furthest distance. it's always from here to there, which is just this line, but it ends here for the smaller radii. I've got a little radii here, which would be this line, and then when I get up to this region right here, the furthest radius is still going to be this line here at x equal negative or x equal 2, but then it changes to this curve. So that's telling me that this would be one volume that I'd have to set up, and this would be a second volume that I would need to set up. I also need to know from where to where. So this is obviously going to be my y equals 0 to y equal 3. I know that the parabola starts here at 3, so I can do that all as one region. That's where this is being revolved. That's like a true washer. It would just be a thick washer that's being revolved here. And it's going to end up on this side over here. It's going to be that true washer here. This cylinder is being removed from the larger cylinder. That's not so bad. And then it's going to have this spike piece here that shoots out, and this like bowl part is being removed from it, if you can visualize that. So I know I'm going to start at y equals 0. This part's going to end at y equal 3. The second integral would have to start at y equal 3, and then I'm going to have to figure out where this point is to know where I'm going to end. And how I would figure that out, I've got this y equal x squared plus 3, and I need to figure out what's happening here when x is 2. So if I plug a 2 in there, 2 squared is 4, 4 plus 3 is 7. This point here must be 2, 7, which means that I would end at a y equals 7. So let's see if we can set this up now. My volume for this first piece is simply running all the way out to here. Now this distance would be 2 minus negative 2. That's a unit, 4 units long. So I'd go the integral from 0 to 3, and those are y equals, for 4 squared, that's the big radius, and I put a pi right on there, minus, now the little radius, see I'm going to go about the line x equal negative 2, but my radius goes all the way out to 0. So 0 minus negative 2 gives me a distance of 2 right there. And so I can call that pi times 2 squared. That's pretty straightforward. This would equal the integral from 0 to 3 of 16 pi minus 4 pi, which would be equal to, I can actually do that subtraction there. In this case that would be 12 pi. The integral from 0 to 3 for 12 pi dy. Now, if I want to put that in our calculator real quick, again, remember that's only going to be this first piece. It's only that first piece that's being revolved. So I'll have to take this answer and add it to another. And so I go 12 pi, second calc, option 7, and I want to go from 0 to 3. And that gives me 113.097 plus, now I have to figure out what's happening with this other region, because I'm going to have to revolve that now. So I'm going to pull out another piece of paper to put over this. On this one, I would say that the volume is equal to the integral, and we already figured that out, that'd be from 3 to 7 pi. Now my biggest distance here, my biggest distance is that one I did earlier. It's going to be units, 4 units long, because it's the 2 minus negative 2. So I'm going to say 4 squared minus Now my smaller distance is going to be this function that I never solved for y. I'm going to have to solve that for y, or in terms of y, so solve for x. So this would be y minus 3 equals x squared. Then I got to root that. So when I root it, I have x equal plus or minus the square root of y minus 3. Because I'm only dealing with the positive part of that parabola, it'd only be the positive root. Now my distance would be that minus negative 2. Minus negative 2 would be a plus 2, so this gets a little more complicated. This becomes radical y minus 3 plus 2. That then has to be squared. And of course all this is dy. So this part becomes a little bit more challenging to put into the calculator. The 4 squared 16, so I got 16 pi minus, now I'm just going to put all of this in parentheses. So I go parentheses square root x minus 3. Remember, everything in the calculator always has to go in as an x. So it's radical x minus 3 plus 2. Close it, square it. Oh, I forgot to put my pi on there. Second, insert pi. So I got my pi on both pieces there. And so then I got the rad y minus 3 is written as rad x minus 3 plus 2 quantity squared. Then I can go to my calculus option there, and this time I want to go from 3 to 7. So I start at 3, end at 7. Took a second to think about that, and then it was giving me a value of 58.643. But if you recall, I'll have to add that to the first part that I had. And so I'm going to take those two answers, add those together. So I'll go 113.097 plus 58.643. And I get a total volume being 171.74 units cubed. Again, it's all about that picture and always looking at what your radius is. You have to determine what that distance is. It'd be the curve minus your axis of revolution. And I did that all the way through. And you saw my formulas as I set those up. And then when I set up the second one, I know it's shaking here, pardon me. This was going to be the line, which was that distance of 4 squared pi. And then it was the curve minus the negative 2. That's why it said plus 2 there. And so that's our example 4 for the disc and washer method. Sometimes you can not have a void, as we did on the first part of that, if you recall. And then that's just the disc method. So disc and washer, example 4.